Okay, so if we take a look at these two scatter diagrams, the one on the left is a negative correlation, and the one on the right is also a negative correlation. But what's the difference between the two? Okay, so when you look at the one on the left, you see it's not as perfect as the one on the right. The graph on the right, or the scatter diagram on the right, is creating a perfectly straight line among the points. The graph on the left is clearly negative correlation. It definitely is. But notice that there are some points that are not in line, and so it's not creating a perfectly straight negative correlation. The negative correlation for the scatter diagram on the right is stronger than that on the left. Okay, so how do we measure the strength of a correlation? We're going to show you that in a minute. Okay, so the length of the strength of the correlation indicates how closely those points can form a perfectly straight line. So if they form a perfectly straight line, we have a very strong correlation. And if they don't form a perfectly straight line, our correlation is not as strong. Now we have a number that can measure the strength of the correlation. Okay, the closer the points of the scatter diagram approximate a straight line, the stronger the linear correlation. To measure how close the points on a scatter diagram come to forming a straight line, we use the following formula. Okay, so this is where we get a numerical measure of strength of a linear correlation. Okay, so this is called Pearson's correlation coefficient. That's what R represents, Pearson's correlation coefficient. And notice that we have a lot of symbols here that we've already seen before. N is the size of a sample. Then we have the capital Greek sigma. We have X and Y representing the X and Y values for the ordered pairs. And then down in the denominator we have square roots and squares, and we've seen things like this when we were constructing the standard deviation. Okay, but I'm not going to be asking you to do this manually. We're going to be using our calculator for this. R is Pearson's correlation coefficient, or a lot of times we'll just refer to it as the correlation coefficient. It measures the strength of a linear relationship between two variables for a sample. So, if we can measure the strength of two variables, we can say definitively whether or not we have a strong correlation or no strong correlation. So X represents the data values for the first variable, where Y represents the data values for the second variable. N is the number of pairs of data values, which is our sample. Okay, the R that comes out of that calculation is a number that ranges from -1 to 1. Okay, so that's how we measure correlation, a number that ranges from -1 to 1. And here's the meaning of it. If we have an R value that comes out to be exactly 1, we have the strongest positive linear correlation possible. It is perfectly positive linear correlation. So the dots move upward from left to right in a perfectly straight line if R is 1. Okay, so all the points of the scatter diagram will lie on a straight line which is sloping upward from left to right. A value of R equals -1 represents the strongest negative linear correlation possible and indicates a perfect negative linear correlation. So it means our points are sloping downward from left to right in a perfectly straight line. So that would give us an R of -1. So all the points of the scatter diagram will lie on a straight line which is sloping downward from left to right. If you have an R of 0, it means that you have no correlation between the two variables. So You got complete randomness in the points on the scatter diagram. So we go from -1, which is strongest negative linear correlation, to 0, which is no linear correlation, to 1, which is strongest positive linear correlation. Okay, so let's look at some visuals. Okay, if we look at these examples, we have the points of our scatter diagram moving upward from left to right in what looks like a perfectly straight pattern. So could we come up with an estimate for R if we were to measure the strength of the variables x and y? Well, in this case, we should note that R has to be equal to 1, okay, because the points of the diagram move upward in a straight linear pattern from left to right. In the second example, we have the points of the diagram moving downward in a straight linear pattern from left to right, which produces a negative correlation. This is in a perfectly straight line, so R has to be -1. In the third example, there's no linear correlation at all, so this would represent an R of 0. Okay, so R of 1, R of -1, R of 0. When we look at the next two examples, we should note that we do have correlation here. It's not an R of 0. There is generally a movement of points that go downward from left to right in this example. So our points are definitely not forming a perfectly straight line, but it's clearly strong in the sense that the points are grouped together and moving downward from left to right. There are low values for x associated with high values of y, and there are high values of x associated with low values of y. And in the last example, the points clearly move upward from left to right, not in a perfect linear form, but definitely in a clearly moving upward from left to right. Now, what do you think the R would be in these two cases? Well, it turns out that they're both very strong correlations, even though they're not perfect. So the R in this case is a -0.98. Okay, it's not -1 exactly, because of course the points are not forming a perfectly straight line, but it is very close because the points are grouped together and moving downward from left to right. In this example, our R is a 0.97, so it's pretty close to perfect, but not quite. And so we see the points moving upward from left to right. Okay, so we're going to take a look at calculating R now. Like, where does this R come from? Well, obviously, we're not going to do, I had mentioned, we're not going to go through the process of using that formula and doing it by hand. We're going to use our calculator, but you'll see how you can arrive at an R value for a set of x and y.